Today we are going to discuss about some gate questions. So here I have come up with two problems. So this is our first problem. Three process P1, P2, P3 arrives at the time 0. Their total execution time is 10, 15, 20 in terms of milliseconds they have given. And what they said, they spend the first 20% of their execution time for doing IO operations, right? And next 60% of the execution time will be utilized by your CPU. And the last 20% again they are doing what? IO. So here what they are asking, for what percentage of time was the CPU free? And they have given a note. You have to use round robin algorithm with a time quantum 5 milliseconds. So time slice is what? 5 milliseconds, right? So for the given data, I have converted the given paragraph into a table. We have P1, P2, P3, three processes. They are arriving at 0. So arrival time is 0 here. Execution time is what? 10, 15, 20, and 20% in the sense what? 20% of 10 is 2, 15 is 3, 20 is 4. And like that, for 60% I have calculate the 60% time of execution time here, which is utilized in your CPU. And the next 20%, that means again 2, 3, 4, that means 2 seconds. The last 2 milliseconds time will be spent for doing IO operation by the process P1. Like that, P2 is taking the time of 3 milliseconds and P3 is taking the time of 4 milliseconds respectively. Okay, so we are just converting the paragraph into a table. So now we have to go with the Gantt chart. If you draw the Gantt chart, that is enough to compute your answer. What is the question? We have to find out at what percentage of time your CPU was free. Yeah. So first I have to go with my Gantt chart. What they said, there are three processes, all are arrived at 0. So everyone will be in a ready queue. So next what I said, what they have given in the sense the first 20% of their execution time for doing IO. First 20% time in the sense what? P1 is spending 2 seconds time in IO. P2 is spending 3 seconds, 3 milliseconds time. P3 is spending 4 milliseconds time. So, who will complete first the IO operation? P1. So, it will complete 2 milliseconds of IO work. After that, it will arrive for ready queue, right? That means for doing CPU burst, right? So for the first 2 seconds, what will happen? The first 2 milliseconds CPU will be idle, because as per our given data, P1 is spending 20% time. That means 2 milliseconds in IO. P2 is spending 3 milliseconds, first 3 milliseconds, and P4 will be there, P3 will be there for 3 milliseconds. Sorry, 4 milliseconds, right? So who will arrive first for doing CPU operation? Obviously your P1, right? This will come first. Next, what I want to do here, I have to apply what? In the CPU burst only, I can apply my algorithm, respective CPU scheduling algorithm, that is round robin, right? So as per round robin scheduling, we are having what? 5 milliseconds. The time quantum is 5 milliseconds. P1 is having what? 6 seconds of work. So in that 6 seconds, P1 is having what? 6 seconds work. So in that 6 seconds, first 5 milliseconds will be spent here. Okay, so within this, who will come? P1 is having 6 seconds work, 6 milliseconds work. P2 will be arriving at the time what? In third second, with the work of what? That is also spending 60% work, no? That with the work of what? 9 second work, 9 millisecond work. In the fourth second, who is arriving? That is P3 with the work of 12 milliseconds, right? So after, when your P1 is executing its 5 millisecond work, if it's checked for the ready queue, there will be two processes, P2 and P3, correct? So with the remaining 5 milliseconds completed here, so with the remaining 1 millisecond work, with that work P1 will go and stand behind what? P3 as per round robin. So it is having 1 millisecond work. So next who is arriving? P2. So P2 will be executing its 5 seconds work again. So with the after that it is having what? With the remaining uh, with the remaining work it will stand behind your P1. Already P1 P3 was there and behind that P1 was there. So it will stand behind what? P1. Next P3. P3 will execute 5 millisecond work and it will stand behind your P2. So next as per Q, who will arrive next? P1, right? So P1 is having only 1 second, 1 millisecond balance work. So it will complete the work and where it will go? It is having what? 20% IO work, remaining work is there, right? So it will go and do the IO process. So here it will go for the IO. So how many second work it is having in for doing IO? 2 seconds. So it will be there for 2 seconds for doing the IO. So next who will come? P2. So P2 is having only 4 seconds balance work already, in total 9, already 5 over here. So remaining 4 seconds work will be done here. Within this 2 second, P1 where it will go? It is already completed. It will do its IO and it will went out from the queue. Right? So P1 total work is completed now. Next, who will come? P3. So where P2 will go? P2 will go and do its IO work, remaining IO work. That is 3 second work. Right? So within this 7 seconds, so P2 will complete its IO work and it will went out from the queue. Next P4 is having what? Remaining 4 millisecond it has to do again the IO, right? So it will go for what? Doing the IO. So for this 4 second it will be in what? IO queue. So P3 will be there in your IO queue. Until that CPU will be what? Idle. So total time idle. How much time the CPU was idle? The first 2 second, 2 millisecond and last 4 milliseconds. So totally 6 millisecond your CPU will be idle. That is your free time. So how to calculate the percentage of CPU free time? What is the total time to complete all three processes? It's 33, right? So I'm within that 33 milliseconds, 6 milliseconds your CPU was free. So CPU free time divided by total time. Obviously, when you are going to calculate the percentage, you want to multiply it with 100. So you'll be getting what? 18.818 percentage. So this is what your answer is, right? So students, hope you understood this, right? I'm having one more question. You just have a try and then you can cross check your result with my result. Okay. So problem 2 here, I read out the problem. Consider three processes P1, P2, P3, the same arrive at 0. The total execution time is 10, 20, 30 milliseconds respectively. First is 20% work they are spending for IO and the next 70% for CPU and last 10% for doing IO again. So here they have given a note, the OS uses shortest remaining time, computing time for scheduling, that is XJF preemptive version, right? Algorithm and schedules a new process either way when running process gets locked. That means this is a statement for defining it as a preemptive, right? Next, what they are asking, for what percentage of time was the CPU was free, right? So how to calculate the CPU percentage? First, you want to convert this paragraph into a table. So here you have a table. So what they said, uh, the P1 is spending first 2 seconds, P2 is spending 4 seconds, first 4 seconds in IO, P3 is spending first 6 seconds in IO. Next, what about the CPU time? P1 is having 7, P2 is having 14 milliseconds. So here only you want to apply your SJF preemptive. Right. So first who will arrive is your P1, right? Next P2, next P3. SJF in the sense what? Even if it is preemptive, no jobs is less than this burst time, right? So obviously how it will work? P1, P2, P3. So P1 will be there for 7 milliseconds, P2 will be there for 14 milliseconds, P3 will be there for 21 milliseconds. After that, P1 will go for doing IO for 1 millisecond, P2 will do its IO for 2 milliseconds, P3 will do its IO for 3 milliseconds. After that, everything will be completed, right? So we want to calculate what? CPU free time again. So here see, first who will arriving? Yes, your P1, it is having first 2 milliseconds, your CPU will be idle. What is the arrival time of P1 is 2 milliseconds. Arrival time of P2 is what? 4 milliseconds, right? So in that way, everything will be work out, right? So first P1 will be there and it will do its work for 7 milliseconds. P2 will do its work for 14 milliseconds and P3 will be doing its work for 21 milliseconds, right? So when P2 comes, where P1 will go, it will go and do its IO operations for 2 seconds. Sorry, for 1 second, right? And when so within the 10th millisecond, P1 will complete the work and it will went out from the entire system. Then what about your P2? When P2 is getting completed by 23rd second, where it will go? It will go and do its IO, right? And what about P3? P3 after completing, so within this time P2 will complete its IO operation. Next P3. So at the 44th second, P3 will complete its CPU burst. Then it will go and do its work, I mean IO work in the IO queue. So there, what is the percentage of time will spend in IO by your process P3? It's 3 milliseconds, right? So in that 3 milliseconds, what your CPU will do? It will be in idle state, right? So totally here 2 milliseconds, here 3 milliseconds, totally 5 milliseconds your CPU will be idle. So what about the total time? It is 47 milliseconds. So 5 milliseconds it will be free. So 5 divided by 47 into 100 will be the answer for the question. Hope you guys understood this. You can get similar questions in Gate forum and practice it. Thank you.